Okay, it's being live streamed. And let me see if I can also record here. You ready? You want to put your slides up? Cool. Hi. Welcome to this Open Security Summit session. Sorry, there you go. Welcome to this Open Security Summit session. We're having Jim Manico, one of the legends from OWASP, here presenting us the brand new OWASP Top 10 2021, which has some very interesting developments that I actually think right on the right direction. So,
I agree.
Actually, Jim, just a smaller request. We're trying to also create smaller videos on this. So when you go to a new one, maybe just ask the question, what is this all about? And then you answer, because I'm assuming you're going to go by each one in turn.
Yes.
So, cool. So over to you, Jim. And let's hear about the new OWASP Top 10 2021.
Folks, I'm gonna move really fast, and I'm gonna talk fast. You're recording it. You always go back and slow it down if you want. But let's rock. I have a lot of slides to get through. This is a big base. So let's go. The OWASP Top 10, 2021 recent release. The OWASP Top 10, it's not a standard. It's a de facto standard that's often misused in formal standards across governments across the world. But please be aware, the OWASP Top 10 is meant to be a very low baseline to get you started for awareness and education. You should not base a program off the OWASP Top 10. And you'll see that in the OWASP Top 10 document itself. They explain, please use us for awareness, not for standard. If you want to base a program off a standard, then you should use the Application Security Verification Standard. We just released version 4.03. But a lot of tool vendors, standards, government policies, they point to the OWASP Top 10 incorrectly. So we need to discuss it. Now, where it's good to do the OWASP Top 10 is for conference talks or education or for developers or security testers who are just starting to get into web security, so we can have a good conversation together. It has its place in the world. The project members, Neil Smithline, Torsten Giggler, Andrew Vanderstock, and the data scientist Brian Glass, I know them all personally. These are great people who are trying to do the right thing and producing this very famous list that gets a lot of international exposure. So I'm a big fan of the OWASP Top 10, and I feel like they're moving in a great direction overall as a project. And the other thing is, hasn't changed that much. What's new is we see insecure design being brought in as a category and server-side request forgery being brought in as a category from the community survey. When the OWASP Top 10 2021 is built, 8 of the items are chosen from the data collection through data analysis through Brian Glass, who is a data scientist, right? The other 2 items are reserved for community voting. So security logging, there's no data that shows us that lack of logging leads to security events. There's very little data showing that server-side request forgery is actually a problem. But the community knows that we need logging to monitor apps properly. So it's an OWASP Top 10 item, even though the data doesn't back it up. Server-side request forgery, we watch Capital One. The Exchange physical server and GitLab all have SSRF problems. So even though it's not a big problem per the data set we evaluated, the community voted it as a big problem. You know why the data doesn't match up to this? Because security tools don't scan or discover SSRF problems well, because a problem across multiple server tiers usually. It's not an easy problem to find. So that's the OWASP Top 10. It's mostly the same with a little bit of a shuffle with a few new categories added in. Let's go through it. Number 1 is broken access control. I am thrilled to see this move to number 1. This is up from the 5th position. 94% of apps have some kind of broken access control. There are 34 common weakness enumerations that map to access control. The biggest problem is indirect object reference. This is where I go to an API and I change the ID and I can see different messages. And the problem is under the hood, they're generating SQL that has no access control built in. So this is a really easy hack. Go to any API in the world that you have legal permission to do so, change the ID. If that gives me access to data that I shouldn't have access to, then we have an access control problem. The security industry calls this indirect object reference. It's just horizontal access control. IDOR makes no sense as a term. I'm sorry, it doesn't. For a developer, I think of this as data-specific access control or horizontal access control, a much better name for this problem. Last, here's how I fix the problem at the database level. I'm saying select data from messages where the ID is the message number and the owner or the recipient must be a user ID, which I get from session or a jot. Now, only the recipient or the sender at the database level is able to read that message. And this is one of many ways I can solve this problem. I can have all kinds of access control designs at higher levels. This is one of many ways to solve it, but this is the biggest problem in access control today. Any pen tester, this becomes an easy way for them to steal data from an application. The other thing is we do a lot of role hard coding in apps. Hard coded roles are ultra weak. This is called a policy enforcement point. It shouldn't be a role because that's the policy. That should be in a database. What you should be doing in code is enforcing by the activity or the feature name. Once you do this, you'll never have to code in the enforcement point again. It implies a centralized, persisted access control store, and we're going to need this for more enterprise or software as a service kind of applications, right? So now I'm just pointing to a pointer that policy represents elsewhere. When I start doing hard-coded roles, if the user is an admin or a manager, that is the policy woven into code, and that's always a bad idea. So other like high-level design principles enforce access control by the activity or feature, not the role. Use roles in the back end. Implement some kind of data contextual access control to solve indirect object references in a generic way, so I don't have to build it from scratch every time as a developer. Your access control for real enterprise software should be centralized in a database of some kind with the filter, so every request must go through your access control layer. I also recommend get denied by default right. If something goes wrong, fail securely, use the right data for access control decisions. Like I've seen cookies with the role, I can edit the cookie, change the role, game over. Make sure your policy is on the back end. And if I change a user's role, like demote them away from an admin, that should take effect immediately. So be careful about access control entitlement caching and have grouping everywhere, grouping of users, data permissions, and so on. Here's the ASVS entry for access control. These requirements represent what I just talked about, but go ahead and review them. ASVS has about a dozen access control requirements. I think we can add a few more. Would love your feedback on that section. So here's a link to the authorization cheat sheet at the cheat sheet series, recent publication. Here's NIST 800-162. This is an American standard. Oh, say, can you see? American standard for access control that you all should read. Even if you don't like American standards, it is exceptional of trying to help the US government move from hard coding roles to more robust access control. A very good read, regardless of where you're from. Also, we got ASVS's access control requirements. That's your homework for this area. All right, where are we? We're at the Open Security Summit. We're looking at the OWASP Top 10. My name's Jim Manico, and we're at A2, cryptographic failure. The original entry was sensitive data exposure, but that's a symptom, not a root cause. The root cause is you broke crypto in your implementation in some way. And we want to make sure that we push developer towards getting crypto right. If you get crypto right in the right places, there'll be less data exposed, right? So number one, use TLS everywhere. Don't tolerate plain text connection. Does anybody have a good reason to use HTTP? The answer is no. Don't use HTTP. You got to use HTTPS on everything, including inside of your intranet. There's no excuse to use HTTP for any reasonable reason. Also, you can use additional standards like certificate of authority authorization, strict transport security, use modern ephemeral cipher suites, use TLS 1, 2, or above, and TLS has gotten radically better in a short amount of time, so use it everywhere in a well-configured way. Also, as we move to JSON Web Tokens, crypto is more important in application security than ever before. You got to understand key life cycle from generation, establish it in software, storing it for use, revoking it, updating it. Key life cycle is so hard. If you go to the world's best cryptographer and say, how do I manage keys? They'll laugh and say, that's your problem, not mine. So this is an application problem that's not solved well. We're trying to figure it out. What's great for application developers is secrets management potential to store your key in a proper key vault is now the norm. Amazon Key Management, HashiCorp Vault, it's a party. There's all kinds of ways to store secrets in an isolated way so we can act on them without giving them to developers. Also, don't write crypto code by hand. Here's Google Tink. Google Tink is one of the best cross-platform crypto libraries. It makes it much harder to misuse cryptography. And I can now do encrypt in Java and decrypt in Android. It's all interoperable. Java, Android, C++, Objective-C, Go, and Python, great languages, right? We also have libsodium, another great applied crypto library for the C-level crowd. Don't write crypto by hand. Use a well-vetted library and keep it up to date. At OWASP, we have the transport layer cheat sheet and the cryptographic storage cheat sheet, well maintained. We also have Dr. Wetter from Germany who has test SSL/SH. That's awesome. Dr. Wetter is a pain in the ass. It's all right. I love him. But what he does in this volunteerism for this script, no more swearing, Dennis, but this is an amazing open source contribution, even though he uses an unethical license. But SSL Labs, on the other hand, is another commercial service that's the de facto standard for evaluating TLS. It's really well done. Moving on. A3 is the injection category, which for the first time since 2003 has been moved down to AO3, to level 3 because we have so much knowledge on stopping and finding injection. There's other issues that are more important. We also took Crosssite scripting, now that we know how to solve it, and merged it into injection, which I'm okay with, right? SQL injection is about inserting untrusted data into a query. It lets me run queries as if I was a developer. This is easy to find these problems in code. Don't build SQL with string building. That should never happen in a secure app. Instead, and by the way, you can't validate. Validation is not a complete strategy because this email address, it's valid and legal and active. You can email me there right now and I'll say believe when I get your email. But this is a valid email address, but it's dangerous. Look at and by the way, here's the regular expression defined in HTML5. And guess what I can use before the at? Single quote is right there. There's my single quote. Equal sign, no problem. Exclamation point, it's in there. There it is. Boom. So all these dangerous characters are legal, even for the most restrictive email standard I can find. It's still legal and it's active. You can email me there right now. Now watch this. Even valid data can cause injection. So many AppSec thinkers say, "Oh, input validation." No, that's not the right top level defense because this is a valid email address. I add it to a query. And look at the final query down here, right? The final query is or1 does not equal manacode.com. That's or true. When I add or true to a query, it dumps the whole customer table. Game over. I got you. So we need something more than validations. And web firewalls only stop part of the problem. So you still want to validate, but be careful. you want to use query parameterization. And that always parameterize your queries. Use placeholders, binding statements, and we're good to go. Now be careful. Sometimes you can't parameterize like a table name. Use exact match validation or redesign it if you run across the problem where you can't parameterize. When it comes to the other form of injection is cross-site scripting. Oh, by the way, here's some resources for you. Bobby Tables and the query parameterization cheat sheet will help you along your way. A3, injection, cross-site scripting, right? This is when I can take content from a user and it gets embedded in a site user interface with no security. I can now add an evil script, embed that in your site, and get my evil script to run in the browser of your users. And so the issue, here's an example of an attack. Here's an attack where I can steal a cookie, right? There's 3 steps to this cross-site scripting attack. I build an evil URL with the victim's cookie. I have an image object that's invisible, and I preload the image, and that makes a GET request and sends your cookie to my server at manacode.com. And there's so much more to be said here because XSS defense is brutally hard. If I want to display data like it was typed in, I got it in code. If the user is authoring HTML, I got to use an HTML sanitizer. I got to use JavaScript right. I can sandbox third-party content. I got trusted types and content security policy as 2 additional standards stop XSS, not to mention HTTP-only cookies to stop XSS. So this is a really hard topic. I do spend 4 to 8 hours in class discussing this if a company has a problem with it when I'm doing professional education. It's hard. Now let's move on. We're looking at the OWASP Top 10. We are now at number 4, insecure design. This is a new category. I support it. It's about so many of the problems are not just low-level technical bugs. They're now architecture design or assumptions around trust models or underlying use of crypto in ways that's not just a crypto problem, also a misuse and design flaw. This is a nod to the threat modeling emerging industry where you want to do design review before making major architectural changes. What do you know? It's a good idea. So there's a lot of other people in the OWASP Foundation that talk about threat modeling. My favorite's Avi Duglin, who's one of the instructors. I want you to go look at other OWASP material to learn more about threat modeling. I focus more on technical bugs, and I'll leave this alone. So let's go to, we're now in the OWASP Top 10, number 5, security misconfiguration. The whole point of this, and this is like 90% of apps have some kind of misconfiguration. It's a common incident. There's 200,000 occurrences of CWEs mapped to this category. It's a big problem as we move to the cloud even more. So, but this topic is, at some level, this topic is a bit awkward because it can span anything from password length to file permissions to access control and more. You got to read the manual for everything and everything in between to get this right. It's a huge amount of work. So we want to find hardening guides and security guides for all of our components and follow them. Like there's hardening guides here for Django, for WordPress, for Struts, for ASP.NET Core, for Spring. These guides are out there to help you configure your frameworks properly. As a start, you should be going through these. Beyond that, you want a subject matter expert in these frameworks to assist you beyond the basic configuration settings. TLS, yeah, I have an A+ at SL Labs because I use this. I use the Mozilla SSL config generator to help me build a good config file for world-class TLS. There's me, A+. Not because I'm smart, because I'm using a tool to help me set up my configuration. And by the way, XXE was part of the last OWASP Top 10, and that's just a configuration problem in your XML parser. So if you still have questions about XXE, there's a cheat sheet to show you how to configure your XML parser in a good way. And so be careful. It's a huge category. It's super complicated. It involves everything in your world. If you can't verify the config, assume it's not secure. Read the manual. go through hardening guides, get access to a subject, get access, Alexa, quiet. Sorry. Also, it's even more important in the world of cloud, right? Even more important in cloud because our whole infrastructure is quickly turning into a YAML file. So read the manual, go through hardening guides, get access to a subject matter expert in your framework. Good luck. Keep it up to date. OWASP Top 10 A6, vulnerable and outdated components. So we saw major incidents like Equifax going down because of an out-of-date third-party library. There are many other incidents I can quote, but this is now this is number 2 in the survey. Wait. Previously, components with known vulnerabilities. It's number 2 in the top 10 community survey. We also had enough data to make it a top 10 via data analysis. So this moves up from number 9 to number 6. It's a known issue that we all struggle with still. I'm pointing out this is WordPress that was vulnerable because of a third-party garbage media library. They were vulnerable to XXE. That lets me read any file off a server with this vulnerable WordPress because of their vulnerable third-party XML library. Here's the Drupal core. Talk about vulnerabilities. Drupal is using the archive tar library earlier this year, which let me have critical attacks against Drupal. So here we have 2 of the biggest content management services on the planet. And within the last couple of months, they both had major third-party library problems that led to critical level public exploits. That's the reality that we're in right now. OWASP has a project called the dependency check, which is brilliant. It should get you started for free and help you negotiate price against the expensive SCA vendors, right? Maven is for Java. There's the NuGet Defense for .NET, Retire.js for JavaScript, and you got Dependabot, which will automatically crawl your code base and issue PRs when a third-party library is out of date. Dependency check, it's a flagship OWASP project, a great place to start for third-party security analysis. And this is a huge problem. I'm just scratching the surface. I recommend that you keep 1 step below the bleeding edge so you're less vulnerable to supply chain attacks. But otherwise, keep your third-party libraries as up to date as you can, 1 step below bleeding edge. We're looking at the OWASP Top 10 A7, identity. There's a ginormous category, and it's down the list in the OWASP Top 10. It's reduced by several positions because we're in an era where we have standardized frameworks and identity providers that do a better job of solving this problem. So authentication is an easier problem to solve in the modern era, I would dare say. What makes this complicated, though, is identity and authentication. They cover many, many other topics, from password issues to credential storage, to look up recovery tokens for forgot passwords and an account recovery, how to handle sessions or modern JSON web tokens, how to handle identity protocols like OAuth 2 and OpenID Connect. It's complicated, super complicated. So, but how strong should your login system be? That's a really good question. So in order to answer this question, can you see? U.S. standards again. I just gave a talk to Canadian researchers. They're all using American standards too. It's great. Don't worry. You don't need UK standards. Go American standards and all is well. I'm being a little comical, or I think I'm funny. No one else does. But let's move on. So NIST 863. The Digital Media Authentication Framework for U.S. government and companies. They have 3 levels of assurance level. A1 means password only. A2, you're doing multi-factor. If you're using SMS, you got to offer another stronger factor like app level push. And AAL level 3 says use FIDO, right? Use FIDO, which is like a YubiKey or a smart card, cryptographic exchange. So, how strong should you be? The standard defines a workflow. All I care about in this, just for this exercise, is low risk of sensitive data, no other risk. Are you high for any of the above? No, I'm not high, Dennis. Do you assess any moderate personal safety? No. Do you have moderate for any of the remaining categories? No. Do you have low for sensitive information? Why, yes. So you should be using some form of multi-factor. If I see an important site using password only, that's negligence in 2021. Multi-factor, at least offering it, is a low baseline for any sensitive data, and I'm still struggling to get some of my clients to move to multi-factor. We should have done that a decade ago. I always recommend multi-factor, but that's just my opinion. The reason why I like NIST 863 is because I now have a very well-written public standard to point to push folks to MFA. So when it comes to policy for passwords, we have a big change in this standard. Again, NIST 863, we're recommending a whole new set of recommendations. From you got to use multi-factor for sensitive data. Don't put context words like your business name into passwords. Don't use the username or the word password for a password. Check against common passwords. Check against breached passwords. Throttle brute force. Get rid of special character rules. Stop using security questions or hints. And stop doing expiration. This is a very different way of doing password policy. But why it's powerful is because it meets up to how we're actually being attacked in the modern era. Why is this a bad password? It's the 32,000th most common password in existence today. And if you get rid of all the junk passwords from common password lists, it's even more popular. Also, it's part of the 600 million passwords that have been breached. It's on public breach lists. And third, it's got the freaking word password in the middle of it. 3 reasons why you should never allow this password. And if you do, that's a major weakness in your authenticator, which you should fix in some way. When we want to store, let's say we're building passwords systems by ourselves. Hopefully, you're not building authentication systems. You're using an identity provider. But if you're building it yourself, there's really only 3 good algorithms for password storage: Argon 2 ID, bcrypt, or scrypt. If you're a US government FIP system, PBKDF2. But I would use Argon 2 ID. If you look at the password storage cheat sheet, they'll give you, I worked with Scoob from the Hashcat team. It's the mathematician from Hashcat who gave me these very specific minimal recommendations around how you should configure your password storage algorithms. So what do we got here? Here's a couple guides. This is the latest ASVS authentication requirements. That's the latest ASVS session management requirements. And if you're an identity professional, please take a look at 863. I know you don't care about US standards, but it's well written and will still give you some good ideas for your own standards you're working on in your neck of the woods. A8, software and data integrity failures. I don't have a lot of slides on this, but the whole idea is when I'm running a CI/CD pipeline, I'm suddenly downloading a dozen scripts off the internet and running them directly in my pipeline. And this is nuts. We've seen multiple instances where these pipeline scripts have been modified by the attacker to attack companies who download and run them. Just think about it. How many scripts do you download and run? And what we recommend is a couple things. Number one, use hashing to make sure the script has not been modified by the attacker. But 2, always do 2 verification steps. So when I'm running a script from like some cloud service on my server, I do 2 things. I check the hash to make sure it matches the integrity of that script. And then I look up the script in GitHub. Usually they're publishing these in public. So I do 2 checks. Is the hash matching? And is it the same as what's in GitHub? After both of those match, then I run the script. And now I'm doing better checks on data integrity for scripts I'm running from third parties. Be careful here. The other thing is that deserialization was rolled into this category. We've known about deserialization since 2016. So that's the other new topic here. This is about very often, it's not your third-party library often, it's your developer code that's to blame, right? I'm sorry, it's often third-party libraries, not your code, that lead to deserialization problems. And software integrity as a new OWASP Top 10 category, look, there's a lot of folks presenting on how to handle all the scripts we're running. It's one of the symptoms of this problematic category. A9 is security logging and monitoring. This was voted in by the community, and I think this is very reasonable. You should be doing security logging so we can identify security events to our SOC team. The goal of logging is to alert on security events, end of story. And we have Nike Corporation in the US that donated this amazing cheat sheet, the application logging vocabulary cheat sheet. This gives us a huge list of events that dev teams should be logging in a real clear fashion. Because the problem is network teams are rarely intaking app logs. They often dump it into Splunk and that's it. And that's garbage, right? We need standardized security events that developers log. Then the SOC needs to know what to look at. Dumping your app logs in Splunk is not helping anything. Having real live events that you can track in a log, because developers used a real standard to specifically in a standardized way log security events. Oh, that's a lot better. For years, I'm like, I log really good security events. We should be all set. But I found out for years, no one's really looking at my logs. So please log the right things and work with your security team to actually be aware of these events and make sure they're consumed properly by your SOC team. There's two cheat sheets. The app log cheat sheet and the basic logging cheat sheet are both good reads. Our last topic of the day is server-side request forgery, right? I'm moving fast. I have a keynote at OWASP coming up, and I'm doing this as a favor to Dennis, because I love Dennis. I'm gonna get in and get out so I can go prep for the keynote. Please forgive me for rushing, but I gotta. So A10, server-side request forgery, is also voted in by the community. The data didn't back this one up. And I agree with this call. SSRF is a pretty big exploit potential. It's even more of a problem with cloud services. And we saw the first big event about 2 years ago when Capital One had 100 million credit card applications stolen. This is the standard location for your Amazon Web Service WAF's credential file. And what happened was Capital One was using a parameter that caused the server to load and embed a resource. And the attacker just changed the URL and Capital One to be this known standard Amazon Web Service WAF file, was able to steal credentials from Capital One and then log in and steal 100 million applications out of the S3 bucket for Capital One's Amazon setup. This is a big deal. There are a lot of people who are talking about this. Orange to Sai is my favorite researcher. Orange, like the orange fruit, to Sai has several YouTubes on this to get more detail. I'll link to him in a second. GitHub had a major SSRF this year. Exchange through proxy login had a mammoth global SSRF in the Exchange server. I've given up on running my own Exchange servers. I'm big into Office 365. It's way more secure to use a cloud service for email, in my opinion. I don't want to run email servers anymore. Here's the actual attack. I'm not going to go through it, but this lets me attack an internal network with SSRF. Here's another way to do it. When I'm attacking an internal service, let's say I'm sending data at step A and adding it to a URL in step B. It looked like this: new URL, my internal site, data, and there's the parameter. It's easy to attack this. As the attacker, they're expecting a number, but this is just an open string parameter that I add this variable to the URL directly right there. Here's my attack, path traversal, and there's the final URL, admin report global. Boom. And this assumes you got bad access control and bad identity on the back end as well. To stop, and you should be URL encoding like this, right? If you're going to add a variable to a URL, encode for URI path or encode for URI parameter. So you're building a URL that your server used to load resources properly using proper URL creation standards. Yeah. So here's a solution. URL encode a parameter that you add to a URL fragment. Or in the case of Capital One, if you're taking a whole URL, validate it to make sure it's a legal URL for your application. Here are some resources that we see. I really want you to watch the Orange to Psy work here at Black Hat and DEF CON. These are the first big talks about server-side request forgery. They're outstanding. And a lot of the world didn't believe him that this is a problem. Jump ahead 3 years later, and we see Equifax and all the exchange users going down because of this problem. Believe me, it's real. Its place on the OWASP Top 10 is just. A few notes. You want great authentication on all of your backend APIs. You want great access control on your backend APIs. And if you have a URL with a parameter, if you have a parameter that's a full URL that your server acts on, do strong URL validation. Also, try to avoid taking a parameter that's a full URL that your server then acts upon. That was a bad design at Capital One. And when you're building a URL for microservice request, build it safely with URL encoding of added parameters. Also, this is a Netflix trick. On any individual service, you can set up network controls and say this service may only make an outbound request to these other services. And now if I'm tricking a service into loading a different resource from a different domain, they're blocked from doing so. I don't like to depend on network security for my architecture, but it does help. And there's a lot of tools that will help me speed up doing this, especially in the world of cloud microservices. That's it for me. A few last notes. Look at the ASVS standard. Look at the cheat sheet series for additional resources on how to develop secure code. Also, we have the OWASP ZAP project, dependency check, and the OWASP testing guide to help you along your way in being a better tester to find security bugs in your applications. Stick a fork in me, I'm done. Does anybody have any questions about anything I talked about?
Great stuff. I have a couple of questions, but I think Ben, you said you had a couple of questions. Should be able to ask them now.
Oh yeah, sorry, I'm mute now. No, that's great. I mean, I think it's really good to get an update. So on the ASVS side of things, I mean, you talked about this. I mean, how do you link these two together? You talked about how with the top 10.
No, first of all, you don't want to link them together. And let me explain why. Hang on for a sec. Let me break out of here. Let's actually go to the OWASP Top 10, right? These are separate artifacts. In fact, the OWASP Top 10 addresses this question in the OWASP Top 10 document itself. And I'm going to go there right now. So how to use it. So the idea is if you want to do training, OWASP Top 10 is entry level only, and the ASVS is comprehensive. If you want to do design and architecture, OWASP Top 10 occasionally is going to help you, but you want the ASVS to help you. If you want a coding standard, secure code review, or peer review checklist, OWASP Top 10 is a bare minimum. Don't use it. You want to use ASVS. Do you get the idea? For any real use, design, secure code, unit testing, integration testing, penetration testing, tool support, so secure the supply chain, it's all about ASVS as a comprehensive standard. The OWASP Top 10 is a awareness doc only that's misused as a standard everywhere. So you don't correlate. You read the OWASP Top 10 once, and then you get rid of it, and then you read ASVS to actually run a program. That's how they're related.
Thank you very much.
It's not just me saying this. This is in the introduction to the OWASP Top 10 itself to really make sure that concept is well known.
Thank you.
Thank you, sir.
Michael, my question from Michael Furnham. Insecure design is a very wide issue. What's your recommendations? Any cheat sheets?
Go. Yeah, let's go look at. There are So go look at the threat modeling topics at OWASP. Right, there's the whole threat modeling, introductory here. There's also the threat modeling cheat sheet, which we've built as well. You can read. There's several other threat modeling. There's the OWASP Threat Dragon, a modeling tool. There's the OWASP Threat Modeling Project. There's so many resources on threat modeling at OWASP. I do it, but I haven't participated in a lot of major threat modeling, so I don't talk about it that much. Go read the other OWASP resources, and there's a lot of other experts that had a whole career of threat modeling. I focus on coding and technical bugs. That's my expertise. Threat modeling is not. So I keep.
No, I think the question was more around insecure design, the A4.
Secure design and threat modeling are the same thing to me. They're the same thing. So secure design, it's just please, and look at all the threat modeling documents to aid you in secure design. That's the best I got. And I also recommend have reference architectures. A lot of professionals, they go into threat modeling meetings to threat model different architecture designs, and they just flop around and have fun. That's nuts. If you're walking into a threat modeling meeting with no other artifacts, it's rarely valuable. So I recommend that your company establish clear reference architectures for mobile, web, and API. And when you go into your threat modeling design meetings, you're enforcing those reference architectures. Otherwise, other people talk about this more than I do. I'm going to pass on any more discussion on this. Next question.
Think we're good, Jim? I know you need to go prepare for your next session. Thanks a lot.
Sir.
Great tour de force, a great introduction. And I see you around.
Dennis, hey, I appreciate the Open Security Summit. Have a great day. I'll see you all soon. Thank you so much.